Hi, my name is J. Kepsi Richard and welcome to my YouTube channel. Today our discussion on calculus of several variables will be on the divergence of a vector field. Before the video will end, I will take you through what a divergence of a vector field means. Then we'll solve some sample questions by finding the divergence of a vector field. This will be a very interesting engagement, so please be my guest. So, if we have a differential operator, this is equal to del over del xi plus del over del yj plus del over del zk, and a vector field, and it's a function dependent on three variables x, y, and z, and it's equal to a function m in the I direction plus a function n in the j direction plus a function p in the k direction. And we are asked to find the divergence of the vector field f. The divergence of f is just the differential operator dot the vector field. So that's how we solve it. And how do we do that? So we can say del dot f will be equal to, what's the differential operator? Del over del x I plus del over del y j plus del over del z k. That dot the vector field, which is m in the I direction plus n in the j direction plus p in the k direction. So what do we do? Remember how to find the dot product of two vectors. The I directions will dot, the j directions, then the k direction in that order. So we have del m over del x, that's this against that, I dot I, then plus del n over del y, then j dot j, then plus del p over del z, then k dot k. Remember, I dot I is 1, j dot j is 1, k dot k is 1. So we can have this, the differential operator dot the vector field will be del m over del x plus del n over del y, then plus del p over del z. So if we are asked to find the divergence of a vector field, we just differentiate the x with respect the differential of the x within the I component, the y will take the j component, then the z will take the k component in that direction. This is very simple. So we take a sample question, then we try to solve. They say, given that f is a vector field depending on three variables x, y, and z is equal to x, y squared z exponent 4 in the I direction plus 2x squared y plus z in the j direction, then plus y cubed z squared in the k direction. We should find the differential operator dot the vector field. So how do we do that? Remember, we say the differential operator del, this is del over del xi plus del over del yj, then plus del over del z in the k direction. Then, if f is the vector field, then del dot f will just be equal to the I directions. So we have del over del x of x, y squared, z exponent 4. This. Then plus del over del y of 2x squared y plus z. That's the j component. Then plus del over del z, y cubed z squared. So what are we going to do? Remember, the i's will dot, n is 1, j's dot 1, k's dot, that will be 1. We perform partial differentiation of this function with respect to x. So what do we do? The y and the z will be held constant. So we have y squared z exponent 4. Then plus the partial differentiation of this function with respect to y. So the x will be held constant. So this 2x squared is constant. When we differentiate that, it will just be a constant. So 2x squared. Then the differentiation of z, since it's constant, it becomes 0. So plus 0 is still 2x squared. Then plus the partial differentiation of this function with respect to z, we'll get 2y cubed z, since the y cubed will be held constant. Then we can say this is a product, or is the dot product between the vector differential, the differential operator and the vector field. I hope you get that. We'll solve another example on this so that you'll be abreast with the concept. So we'll solve our second question. They say if f depending on x, y, and z is equal to the square root of x, y squared z in the I direction plus 2x tan inverse of y in the j direction plus xy arc cos z in the k direction, we should find the divergence of f. Remember, the divergence of f, is just the differential operator dot f, if you recollect very well. And what is the differential operator? The differential operator is giving us del over del xi plus del over del yj plus del over del z in the k direction. Then we can say that del dot f will be equal to, so the i's will multiply, j's multiply, k's multiply. If you remember how to dot a vector is very well. So we can say this is del over del x, the differential of the square root of x, y squared, z, plus del over del y, the differential of 2x tan inverse of y, then plus del over del z, the differential of xy arc cos z. Remember, arc cos is just the inverse of cos and nothing else. It's just there to confuse you. So what we have the dot product between the differential operator and f will be equal to, now we are going to differentiate this function with respect to x. So the y and the z will be held constant. When we differentiate the square root of x, we get 1 over 2 root x. Then we repeat the other variable y squared z. Then plus, how do we differentiate this function with respect to y? So the 2x will be held constant. How do we differentiate tan inverse of y? Tan inverse of y will just be 1 over 1 plus y squared. Then plus, now we are going to differentiate this with respect to z. The x and the y will be held constant. The differential of cos inverse, that arc cos inverse of z will be negative 1 all over the square root of 1 minus z squared. So, after polishing, we say that the differential operator dot f, or the divergence, will be equal to y squared z all over 2 root x, then plus 2x over 1 plus y squared, then minus xy over the square root of 1 minus z squared. I hope you get that. So this is very simple, and I know you will understand this. So solve our third question on this. They say if f is a vector field and is giving us a function f depending on 3 variables x, y, and z, and it is equal to cos the square root of x, y cubed, z squared in the I direction plus 3x squared dash inverse of 2y z in the j direction, then plus xy squared e exponent times z in the k direction. We should find def f. So if you see def f, it means the divergence of the vector field f. So we can say that def f is equal to the vector differential operator dot f. So what is the vector differential operator? The vector differential operator will be equal to del over del xi plus del over del yj, then plus del over del z. So that means the dot product between this and that is just the I components multiply each other. So our del dot f will be equal to del over del x times cos root x y cube z square, then plus del over del y 3x square dash inverse of 2y z in the j direction. Okay. Since it's dot, the scalars will not come in. Then plus del over del z x y square e exponent times z. So what do we do? We perform partial differentiation and we are good to go. So this will be equal to, now perform partial differentiation on this function with respect to x. So what do we do? If you differentiate this very well, you get sin root x over 2 root x, then times our y cube z square, then plus the differentiation of this with respect to y. So the 3x square and the z will be held constant. So we have 3x square. The differential of this will just be 2 over 1 minus 4y square. Please check out my videos on the differentiation of inverse hyperbolic functions. So then our z will come, then plus, we'll perform partial differentiation of this with respect to z. So our x, y square will be held constant. Remember how to differentiate exponential function. We differentiate the exponent and use it to multiply the function. When you differentiate times z, you get sec square z, then e exponent times z. So on polish this very well, we can say our def f is equal to y cube z square sin the square root of x all over 2 root x, then plus this time used to give us 6x square z over 1 minus 4y square. Then this will just be xy square sec square z e exponent times z, and you will be abreast with it. So please remember to subscribe to my YouTube channel before you sign off. We'll end it here today. Like my video, comment. Your comment keep me going. So comment and share my videos for my YouTube channel to grow so that I can record more mathematical content for you. Until we meet again on calculus of several variables, my name is TTJ Kepsi Richard.